Hi, I'm Harry, the founder and managing director of Gramm, and I wanted to give you a quick and short and first preview of our upcoming virtual reality app, Manifest. So you actually spawn a little bit further back, but I wanted to give you a view of the vista right away. So this is the main learning station right now. So we've encapsulated them into buildings. And this is about the process category material extrusion of 3D printing, particularly the 3D printing technology, fused filament fabrication. I think a lot of you are familiar with this. That's why we're starting with this technology. Of course, in additive manufacturing, there are many more process categories and many different technologies that we want to bring to you in this format so that you can learn about them, learn how they can be best applied, so that you're getting a good overview of the technological landscape of additive manufacturing, and that you're able to leverage your additive manufacturing potential easily. So as I walk down here, I get an overview of the different stations that are in this larger substation. And as I do them all along, these yellow balls turn into green check marks, and that's how I know how I mastered the station. Now, mind you, this is still in beta stage. So while the content is fairly stable for fused filament fabrication, some things are still going to change, like how we are going to visualize the learning, your learning path and your progress on it, and a few other things. But you should get a view of the general gist of it. So, and you already see early on a lot of the philosophy that went into this. So there is a wide path guiding you through this station, but in principle, you're free to go wherever you please. So there's nothing stopping you to go directly over there if I want to explore this first, or if I've done the other stations already in an earlier stage. But of course, but there is a suggestion about an optimal path that builds where each station builds upon the next. So this is the first station. This is the printer type station. So you see that over here, and here you see the different versions of FFF printers that there are out there. So you see a Delta printer that have this where the extruder is kind of hanging from the axis, and it's building up vertically very fast. This is really good for rotationally symmetric parts, and particularly parts that are tall but don't have too much of a footprint. Here you see an FFF printer where the Z-axis is moved through the build plate, so where the build plate moves in the Z direction, and the extruder moves in the XY direction. So, for example, the Ultimaker printers, I think, use this principle. And here you see an FFF printer where the build plate moves in the Y direction, but not in the Z direction, and the extruder moves in the X and Z direction. So different principles, they're fairly similar in results. They have, I think, more implications on cost and how challenging it is to produce these systems. And you see auxiliary information up here on the view screen for this particular station. Now the texts are still going to be edited for the release. But you see the principle. And then when I click on print here, I start the animations, and I can have a closer look at how this printer is actually operating. Here the axis is not moving, but we have a larger printer of the same kind that's going to demonstrate it much better. The Delta printer is static, unfortunately. So, and you see here in terms of learning, and we're talking about learning here, not about teaching. You see that the first station has now been completed, so that was a fairly easy one. And the next station is really interesting. That's the one with this really big printer here. So here you have a build-up lesson, and what's going to happen is here we're going to sequentially build up the individual elements of the printer. So first, this is the frame, then the front display. So you need a user interface and how to interact with the printer. Here the SD card goes in, and here you control the display here. The important part about this element is that there is every 3D printer has some sort of a human machine interface. So now I don't know of any 3D printer, also not in other process categories, where the printer is so autonomously and digitally controlled that there is no way of interacting with it manually. I mean, in the simplest way, you always have to remove the parts from a printer. There's always a person that has to interact with the printer. Next step is the build plate. So it's very important in fused filament fabrication. Build plate is also really important to understand how do I need to design my parts that they don't have any warping, that they stick to the build plate with the goal of maintaining quality, maintaining particular dimensional accuracy, and avoiding failed prints. Then the Z axis, so this is the direction in which they're built up. So printers are built layer by layer. I mean, of course, element by element, but grouped into the layers. Then it's built up layer by layer. And the Z direction is always the build direction. That's the direction in which the layers or the slices, better to say, are stacked. Then we have the x-axis, and as I said earlier, so this moves for this extruder type, for this machine type. The extruder moves along this axis. Here we have the extruder, and then we have the filament, the feedstock. So if you're very familiar with additive manufacturing, then yeah, you're going to say, oh, this is all very obvious. Of course, we're going to apply the same principle to other more complex 3D printing technologies that are a bit more difficult to understand. And even here, this here teaches you the fundamental principle, and then you can apply it to more complex systems like binder jetting systems, powder bed fusion systems, and so on. And for example, with powder bed fusion systems, the feedstock, the material has its own cycle, and that cycle is essential to understand the process where its advantages and disadvantages are. Okay. And then these stairs, of course, they are not there with a real printer. It's a little bit smaller. But I mean, of course, there are material extrusion types printer, particularly in construction, that actually have this size or larger. So as I explore this printer, so I get a new task here. So I should look for a switch to turn the printer on. And that's over here. I always really like this. I like this idea of interacting, of having interactive 3D objects in a virtual space. So I like that. I mean, as much as I like printing parts, this is always really exciting too. I think an interactive digital model is always the best compared to a static one. So we actually took some time to recording the all of authentic sound effects here and the beep, and now the printer is ready to operate. And now I have to go up and inspect it again. Oops. So search for a switch to turn the printer on. I already did that. And now it's time to print. Wait, is it correct? Hang on, that might actually be... I have to press the button here, I think. Yeah, that was the thing. Sorry, I forgot about that. We don't have an animation yet for building our parts. Actually, this model was built in Blender, and the original Blender model that we have already can do that. You can actually buy our model on that animated printer model on Blender Market. You also find it if you go to our website. And then we can print arbitrary objects. We just didn't have time to bring it in here yet because there's quite a bit of code transfer to do. But that should be in there soon. So, but I still really like this model. I think it's really fun to explore it this way. And in particular, if you haven't had any exposure to FDM printing before, this is a really good introduction. And so now, after you've learned all the individual elements here, okay, we go over to the next station. And now here, your task is to actually assemble this printer. So where we've presented you with information here in a fun way, in an interactive way, now it's time also in an interactive station to apply what we learned over here today. So you see all the individual elements of the printers here, and you have to build it up here now. So this will, I mean, from a learning perspective, I'm not an academic when it comes to teaching and learning, but basically you're reinforcing the information that you just acquired, and in a very intuitive way, because you're using your hands and your body, which I think is really important to learn things quickly and intuitively. And that really helps with the learning process. So you learn faster and you retain more of the information. So here I have my frame, and I'm building the second part of the frame. What's important here is this is not assembly instructions on how to assemble an FFF printer or a particular FFF printer model. It's way too abstract for that. So we're just using assembling the printer as a educational exercise so that you learn about the relevant or the critical or the necessary elements of an FFF printer. So these are the two axes here. So, and the extruder, hang on. Here, put that over here. I'm left-handed, so I like to really grab things. I also think that grabbing is a really, really great way of interacting with objects. I mean, many of your applications have that. But there on the right hand, what you see here, this red line, that's a grabbing laser. And you can actually grab something by pressing the button that's on your middle finger on your MetaQuest 2. And then you can use the analog stick to actually move it back and forth. So you can, if you don't like to move around, you can manipulate these parts really, really easily and place them very easily, and then just let go. Might also help if you're right-handed. You maybe want to do this with your dominant hand. Yeah. Then there's the build plate. And there's the filament. Hang on, let me grab it this way. So I'm actually having a bug right now where I can move. So I'm gonna finish up this exercise, and then I'll probably stop the video and then restart it at this situation again. So that's that's got to be fixed for release for sure. And then I built it up. I get a really nice positive feedback here. And if you look over there, I don't know if you can see it from the resolution, that station has also been finished. So I see you in a moment when I've reset the avatar. Hi, so I'm back, and you see here I had to restart the level, but the application, but I finished building up the printer, as you can see here. Looks really nice. And if you go over here now, I had to restart because of a bug. You see that I've finished the first 3 stations. So that's pretty good. So it was really important to me to have to us to have the progress in a modularized as much as possible, so that you can do different stations in a different order, but you still have a clear representation of your progress through additive manufacturing technology, in particular here with fused filament fabrication. So in here, this station is something that I really like because I like to think in processes, and that's probably still going to change a little bit until release, because this is a heavily simplified version of this process chain, but it's really easy to make that change, and we made that station so that we can use it for many different process chains and process sequences in additive manufacturing. So here you see the presentation of the information, as I said earlier, presentation, interactive presentation, and interactive reinforcement. But here, this is very static, of course. So you just see this, you study this, and then, I mean, it will be removed a little bit from each other so that you don't just copy it in the release. But then you're asked to take this process chain, this chevron process, and replace it here. So you see all the different tiles on the floor, and now you have to think about these specific subsets. So this is how additive manufacturing can be modeled, or how we model it. So you always have pre-processing, which is build preparation, then you have in-processing, which is a build cycle, then you have post-processing, which is the finishing, right? And it's these are different for every 3D printing technology and every process category, but of course with some similarities. And now we're dealing with FFF printing in particular. So I'm going to start with pre-processing. So the first thing I have to do is I have to place the parts on the build plate in my build preparation software. So again, this is here heavily simplified. And then I need to add the supports. Well, this is also necessary if the parts need support. Optimally, an FFF part would need support. What should be in between here is orienting the parts and then placing the parts, or even nesting the parts. And of course, setting the build parameters. But again, for the development build, this is an earlier development build. kept it as simple as possible. And then I have to generate the job file. So that's really important. The job file is that what the machine gets, and that's just a toolpath to be executed layer by layer, and then the extruder moves up. So the machine has no understanding of 3D in that sense here, but it builds a three-dimensional part. And in the build cycle, you start the job with layer-wise additive shaping. So again, we heavily simplified that here for this development build, and then the job is finished. And then we move on to post-processing. So you have to remove the parts from the platform. So in reality, I mean, this is a very obvious thing that you have to do, but in reality, so in a production environment, it's actually a real requirement, because you cannot start the next job until you remove the parts. So that has implication on scheduling if you're looking at mass manufacturing. And of course, depending on your build plate and depending on the material you use in fused filament fabrication, you may have to adjust your design to actually make the parts removable. So I don't want to go into too much detail here, but just important that there are many practical considerations that originate from this very simple logical step of removing the parts. And then, of course, you have to remove the parts from the part. And lucky me, I did all of this correctly. So I get a nice green check mark. And if we look over there, or if we move over there, oh, boy, that's fast. We have a sprint button here. Normal movement is slower. You see that the process chain station, there's a T missing, has also been finished. So I'm making my way through this quite quickly. And then I move on to the next station, which is actually several individual stations that form one larger station. That's actually our old logo. So we put some decals here and there that we can play around with. Okay, and here is the build preparation lesson. So here the TV is actually interactive, like it was with the big printer, where I can look up, okay, data preparation. So overview of what to do. I have to clean the printer. So that actually means clean the build plate. And that's really important when you start a new print. You want to check your build plate, whether there's any residue from the previous print. And sometimes you have to really clean it with a chemical solution, the build plate, I mean, because you're changing materials in between. And then you turn on the printer, you load the printer with the material, then you insert the SD card with the G code in the printer, and you start the printing job. So let's clean the printer first, and that's 2 steps. So I need a cloth. It's a particular type of cloth that you should use. And then the cleaning solution. So this is isopropanol, which is an IPA. Is it IPA or is that beer? Yeah, I think it's IPA. The chemical solution is all called IPA, just like the beer. And that is usually a good solution to clean. Sometimes you're using acetone to clean stuff, but that's for most build plates not good. So let me try this again. The cloth should have changed color with that. And then I clean the build plate. I'm not getting feedback here, so I just have to assume that I did this correctly. This I really like, that you can switch this over. And this is really, really nice. And then I put it up here. So I've loaded it with material. And then insert the I think, wait, I actually have to move something from over here, no? Oh, I forgot something. I forgot to turn on the printer, right? That's correct. So I have to turn it on as I did before. That's now turned on. And I think, I can't move that anymore. And insert the SD code. So it goes in here. I mean, that's for a particular model, right? Other models, the location may be different, but it's still the same thing. So that's a fully prepared machine. Powered on, cleaned, filament loaded with the correct filament and material, correct filament, of course, material and color, and loaded up with the G code. And now you can start the printing job. So if I press here, I don't think it does anything, but I got the feedback already, so I finished that one up. And then the workflow station. So this is how you print the part. So here the first thing is I turn on the printer. So we split that up into different sections. So this is what you do. This is basically within the in-processing, that's the preparation step. And now this is the actual build cycle. So I turned on the printer. And then I click on start the print, and of course normally it takes a lot longer, but here my print is finished, and I finished the station. It was very simple. We just thought that logically we want to separate those steps, because during the preparation stage, you're at the printer, you're working with the printer, and if you take like laser metal particle fusion, this stage is much more involved. And then the actual build cycle is mostly autonomous. I mean, that can even take place overnight or on the weekend, and so you don't have to do anything here. Hang on, just have to turn here. And now this is a post-processing station. This is actually less about the printer and it's more about the pods, right? So I have to take the pod off the platform. And I think for that I have to, this may actually, there may be a feature missing here. Let me check. So I want to take the part off. So I think the part is missing. No, I don't have the part here. But here's what you simply will learn, that you have to take the part and remove it from the post-processing. So I don't think it's going to let me do that. I don't want to spend too much time on it. Let's take the SD card out. And I drop the pliers, put them back here. Oh, I cannot take this part. No. Okay, but that's a really simple fix. So here you learn, remove the parts from the platform and remove the ports from the parts and otherwise finish them. So that's that station. So unfortunately, I'm not going to get to finish the print workflow in this demo, but I mean, that's why it's a development build. So by release, it will be fixed. And but I think overall, I mean, this is quite impressive. So you have a lot of modern learning experiences or ways of learning. And it's very much this is a self-learning, self-paced learning environment. It's not a teaching environment, it's a learning environment. And so I really, really like that, because that's how I like to learn. And I mean, it's in virtual reality, so we can actually present a lot of content, particularly machines, which are interactive, which are dynamic physical systems. And I think to display a dynamic physical system, virtual reality is the perfect medium. And of course, the technology, 3D printing, additive manufacturing, is very new and still in its early stages of becoming fully utilized. So it's an exciting technology to learn about. So I really think that we're bringing three great things together here. So I really, really like this app, and I'm really happy that we managed to get it done. So the material exercise station, this is where you learn the different material types and what their different properties are. And you're also automatically comparing them to each other. So here we still have to fill in a little bit more text and lines and so on. But you're actually starting with this station here. This is where you learn about the material. So this is very simple, where you change the color. That's not particularly important right now. And then you have text here that explains everything to you. And then we go through the different, it's already here. So you see the different material types. And we focus right now on the thermal properties. So when does it melt, and what is how up to what temperature is it? Does it remain solid, and when starts to get soft and deformable? And you see that here for the different materials. So PLA is great to print. There's actually a subcategory of PLA Plus that I think we should also present here, that has the printing qualities of PLA, but better mechanical properties. PETG, and also this is a bioplastic, so this is why we really like it. So it's made from organic material, and it's actually fairly easy to recycle. It's not so true about PETG and ASA, but of course, if your application requires it, those are great parts. ABS, I mean, it is there, but if you want to print with ABS, you want to print with ASA. So whenever you're trying to print an ABS part, just ask for an ASA part. And TPU is always exciting. I'm always surprised. I mean, we have other machines for flexible materials, but the TPUs in FFF have been getting really, really good, and you get no delamination if you configure the machine correctly and you have good material. So you can make really great flexible parts with FDM as well. And I mean, we have 20 FDM FFF printers ourselves that we operate in a print farm, the different models. And we've been producing parts in them for literally years, and end-use components. So series manufacturing, cover casings, fixtures, and other things, mostly mechanical parts, some design objects as well. And it's really amazing because you see it every day, the type of parts that it can produce. And then especially if a customer reorders a certain type of part, you know that they were happy with it and they need more of them, so that this is that's not a prototype, that's end-use manufacturing. So similar to the process chain station, I have all the have different temperatures here, and I have different temperature thermal property categories here on the left, and then my material type. So here, for example, the softening temperature, it's now asking me to assign the correct value to PLA, PETG, PLA, RBS, and TPU. So, okay, so let me see if I can get this right. I'm probably not going to get all of them right, but I'll do my very best. So I see green. So these are all of the green ones. So what I know is that PLA has the lowest softening temperature. So it's the one that gets soft the soonest. Yeah, and that I'm correct. Now the other ones is a little bit more difficult. I think TPU is actually surprising because it has a fairly high temperature. And you see actually here that there's 3 with the same temperature. But this is PETG, right? 80 degrees Celsius. We should probably have like a flag that converts it to Fahrenheit. I'm not sure that we can manage by release, but we'll think about it. So now that I see it for the first time and that we're going to launch this app in English, so it's probably going to be a lot of people from the United States interested. But I mean, of course, if you're interested in 3D printing, you know about different ways of quantifying temperature. So this, I think this should actually be ARSA, right, from over here. So we need to replace this. And ARSA, of course, is a very high softening temperature. So this one's correct. This one's not correct, even though it's the same value as here. That's just because we have to fix this with the assignment. We're just going to change the colors here somehow. So that was a TPU's plate. But it is, of course, correct. That's also going to be fixed by release. Again, this is a development build. Now, the melting temperature. So I build a lot of parts, so I should probably know this. I mean, for PLA, it's clear it's 190 to 210 degrees. Yeah, sometimes even 215, depends on the material. And then 240 to 260, that's for ARSA. Right, so again, this is ARSA, it's just the wrong label. 210 to 240, that's RBS. It's a little bit lower. 200 to 230 is PETG, so that's clear. And this one is TPU. Okay. And then the heat bed temperature. Okay, what do we have here? Yeah, for PLA, it's around 60 degrees Celsius. Depends a little bit on the particular flavor that you have of PLA. And I mean, PLA you can sometimes build without any heat bed, but we actually always turn it on. And then, no, this is not correct. I think TPU, yeah, can do it with a lower temperature. I think it's probably because it's very sticky, so it's not, you don't have to heat it up too much to get it to stick enough to the build plate. And yeah, that's PETG. It's only 70 to 90 degrees. I think we have like 90 for the first layer and then 70. And these ones again are the same. So you see here, they're actually very similar ARSA. Again, this is ARSA and RBS in properties. It's just that ARSA is much easier to print, and that's why we prefer it. So form stability, that should be 70 degrees, PETG, and PLA 65 degrees. It's probably a little bit more difference here, but PETG is, you want it for mechanical reasons because it has the mechanical properties of ABS, but not its thermal properties. And these here are all form stable until around 100 degrees. I think for ARSA and RBS, it's even a little bit better. Yeah, and there you go. So I'm actually a little bit happy that I managed to get most of them correctly. I only got a mistake here, but that was just because of the programmed logic, and the input was really correct. So I finished the material station, and I have the print workflow. I also finished it such that this machine, this substation needs a break. So I've completed, so that's basically a let's play or a playthrough of this entire station. Of course, with release, we're going to have more content, and I think it's still very different and much more exciting if you try it out for yourself. And your learning experience and the retention of the taught information and skills is going to be different. So I really hope you like this. I'm going to edit the 2 videos together and put them out on LinkedIn. And I'm probably going to make a blog post on our webpage too. And I'm really excited to hear your feedback about this, whether you got a good, whether this video gave you a good overview of what the app actually does, and what you think about the way that we're presenting the information here. And of course, if you're interested in getting the app, let me know. And if you are looking for something more custom for your enterprise or your business, then please also get in touch with us. We work with a lot of corporations, both small, mid-sized, and large corporations. So that's maybe they have some custom needs in the field of 3D printing and VR that we can help you with. Anyway, so I'm really happy to share this with you, and I hope you liked it, and I'm looking forward to your feedback. Thanks.